Hello, we're team number 6, and we're going to be discussing our project on computer vision for object detection in medicine, in collaboration with the GOSH Drive unit, a part of Great Ormond Street Hospital. In this project, we were tasked with finding a new way to use computer vision and object detection to detect medical objects. After careful consideration, the team decided to create a medical detection system, which could detect medical instruments on an operation tray and store data regarding when they were used during the operation. The system is designed to log medical instruments when they are placed on the operating tray and store them to the database. This data can be used to gather statistics about the operation, such as what instrument was used for the longest period of time. The system also gives the user a complete list of the instruments that have been used during the entire operation and checks whether they are all accounted for when the operation is over. We also decided to find the limitations of the object detection system and see whether or not it would be possible to use in real-life situations. One of the main goals of the project was to see if the system distinguishes the objects with a high level of accuracy. The system is separated into two main components, the client and the cloud service. The client section of the system refers to the local computer which the user uses to run the system. The cloud service, on the other hand, is used for processing the data gathered by the client and detecting the instruments seen on the video stream. This detection is done by using a detection model trained specifically on the set of objects used for this project. The data gathered by the cloud service is then stored in a database, which is used to run analytics on the operations. When creating the system, we realized that the process of detecting images required substantial processing power. In order to decrease costs, we decided to have all the processing done on a virtual machine, which would process the detection of multiple systems simultaneously. This removes the need for the client system to have strong processing power, as all the main processing is done in the virtual machine. Having trained the model beforehand, the team was able to place the model on the virtual machine and process the information sent back and forth to the client using a web API. In order to create the system, we decided to use Google TensorFlow object detection in order to train our model to distinguish these instruments. The team decided to make the front end of the system using a Python graphical user interface called PyQt, as both that and TensorFlow use Python as their coding language. This made connecting the back end and front end incredibly fast and simple, as they were both written in Python. In order to process this detection, we decided to use Azure to host our virtual machine, as Azure is already used by our client in their other systems. The system itself starts with the login page. By logging in, doctors will be able to see their own operation statistics. However, the application can still be easily accessed using the emergency login button. After logging in, the application tracks the medical instruments in the live feed and constantly updates the live list of any changes. After clicking the Start operation, the changes in the live feed are logged to the database, which can be viewed later to give a whole operation overview. The system has been trained to detect objects in different lightings and backgrounds with a high level of accuracy, even if the objects are very similar. As you can see, the list is constantly updated when items are being added and removed. Once the operation is complete, the Stop button is pressed and a list of all the objects used and objects missing in the view are shown. The user can then click on the missing items when they have been placed back, ensuring all instruments have been accounted for. The Statistics button can also be pressed, opening a new window which shows the timeline of when instruments have been taken and put back in the view. The system then allows the user to toggle between the two windows in order to get a comprehensive view of the operation. The user is then able to press Logout and go back to the login page where the system is ready to start another operation. The system is currently able to detect medical instruments with a high level of accuracy. By being able to detect these instruments, the system can gather data regarding each instrument, when it was used and for how long. By gathering this data from the operation, doctors will be able to gain insight into their procedures and find ways in which they can improve them. This data can also help train future medical professionals, as they will be able to access real-life information about different operations, which can help them gain a better and more detailed understanding of the procedures. This was Team 6's project for computer vision for object detection in medicine.